So, before we begin, big shout out to all my Patreons and thank you for all the support. You can support me on patreon.com/C#accent, where with $5 or more you can get, as a reward, you will get all the scripts I made in the videos with additional comments and some notes that sometimes I forget to mention in the videos. So, in this new series that I'm starting, as you can see, it will have a medieval theme, and it's going to be inspired from the game Mount & Blade. Now, if you do not know the game, I suggest you pick it up. And in Mount & Blade or this game that we will create here, we will have a melee game where we use swords and other stuff like this to attack. Now I'm going to be heavily inspired by Mount & Blade, so some stuff you might not want to use them in your own game, or you might have other animations. Now I have to mention that our weak part is going to be the animations in this series, and as with the previous third-person shooter series, the animation was a problem, and that is why you have to spend at least some amount of money to buy some good animations, especially for locomotion. Now you will find in the description below a link with the attack animations I have created, which is this over here, which you see, and the moving forward and backwards. But for the video I've changed the animations where we strafe left and right. These are actually animations that I've bought, and those are actually animations from a third-person shooter game, but I'm blending with mechanism. So I have the upper body into a different layer so that we can start so that we can attack while we are moving. Okay, but in the package below you will find some different animations where the only free ones I could find, so that we'll have to do, or you can switch them with what you have. Now in this video we will focus mainly on how we move, on how we attack, and if you can see, if I go and hit too close to a wall, you will see that my attack is actually interrupted, and when I click the mouse I have half a second to decide which attack it will make, and this attack and the way we choose which attack we will do, we hit the left mouse button and we move it towards a direction. So if I move it up, it will make this it will point it forward. If I make it to the left, it will point it left. If I make it to the right, it should make it swing from the right. And we will also do the blocking the same way, left and to the right, which right now it doesn't work. No, yeah, it works. And if you have played other games like Chivalry, where they have multiplayer, if you move the block, if you do the upper block and start doing down, you challenge another player. We will probably do multiplayer, but later, because I want to cover most of the things that Mount & Blade had. That includes mount with horses, and the campaign map, of course, enemy AI, and finally campaign AI. And of course we can hit other game objects that have a rigid body. So let's start. Now the camera I'm using is from the third-person shooter series, but I'm going to include the scripts so that you can start following the video without having to see another one. So you will find the link in the description below. Now these are the values I'm going to use for the camera. Let me maximize that. For the third-person shooter series, we had the tilt max and the tilt minimum, some different values. I don't remember which one were there, because we don't want to hit when we are looking to the ground. We don't want to hit too much way down, and of course the rotation over here, you see, it's not that ideal, but let us not worry about that. So after you download the project, you will find in the animations folder, you will find a Challenger animations, the .blend, and you will find the other animations and the controller. You will only have one controller. This is the one I'm going to use. It has some assets that are paid, so I can redistribute them. So the character, of course, is the Challenger from the blacksmith video. You can download it for free in the asset store. The Viking Village, of course, is also from Unity Technologies. Is also free in the asset store. They are great packages, and you can download them for free. Of course, they are not required to follow this tutorial. If you have a different character, you can do it, but I don't know if these animations are going to work too good for your own characters. Now let's start with a camera so that we can get rid of this right now. You'll create an empty game object. Inside that empty game object, you will create another empty game object with which it will start as the pivot. So our camera will rotate from this. This will be the pivot point of our camera, so it will rotate around over here, and of course drop our main camera inside. I've also added some image effects just to make it look prettier, and for right now I'm going to close the camera motion blur because if you're lagging a lot of the time you might get dizzy. Now some image effects are bought from the asset store. Of course you can use, if you have them, you can use them, or you can use the ones Unity provides. Now create an empty game object first of all, and inside you will add the model. Now if you use the same character as I do, it's best not to use this model I provided from the package. It's best to download the one from the asset store, because you have the textures and you have all of them. Okay, and you might avoid some troubles later down the road. Now on the empty game object, of course, center it. This has to be everything at 0, and of course you need to turn it into a humanoid rig. Now you will need a rigid body. I've raised the drag to 5, of course, and you will also need a capsule collider and make it around the size of this. It will be okay, and you will add the script we are going to write. I'm going to disable this, and then on the sword, for now, of course, put the sword into his hand. We're not going to go with sheathing and unsheathing. We have covered that in the third-person shooter series, so you can watch that and choose from there what do you want for your own game, or if you do not want something like that. Okay, so I'm not going to do any pickable items and stuff like this since we have already covered this. So for the sword, you don't need the animator. Now you will start with just the first box collider, which is the trigger, and a rigid body, since we are going to be moving this independently from the first from this collider, since this will be moving with animations. So I figured it's probably best to have its own rigid body, so you probably squeeze a little more performance this way, I don't know for sure. And of course you want it to be kinematic so that it doesn't be affected by forces. Then this collider you will see later, and later the script we are going to write in a bit. Now one other thing we want to do is we do not want this collider and the colliders for our weapons to be interacting with physics with our character's collider, because we will start having a lot of strange behaviors. So in order to avoid that, we will create new layers, one layer for the weapons and one layer for the character. For the character, you will also go and assign the layer, which is characters, but you only want to assign this in this game object. So every collider over here will have a different will be at the default layer, and on the next video we will actually have position damage, and we will create a few enemies to hit around probably. So for now, just add this to the character layers and the sword to the weapons layer, and also add a weapons tag, although we might be able to do it a little bit different, so we might not even need this. Now a big part of this, the way we are going to do that, is how we will make the animator. So let's take a look at the animator. Now for our base layer, you will see, now of course I don't have a good idle animation right now, so it's just a freeze frame from the walking animation. Now of course you can fix that with some FootIK, you can probably fix that, but I'm not going to bother too much with it. So you will need, let's put them up here. So forward and sideways you will need two flows. Make it a 2D freeform Cartesian, parameters of course sideways and forward, and then on position x -1 you have the same animation like the walking, like when we walk forward, not this, oh, these are actually the other way around, but anyway. So it's the same animation like walking forward, but if you see here we have negative speed, so that means the animation plays the other way, and it kinda looks okay for walking backwards. So without having an animation, we actually can reuse the walk animation for that. And for strafe left and strafe right, of course -1 or just 1. Now as you can see, he's trying to hold a rifle over here. So because these animations are not correct, of course, because they are not even from the same rig, we will create a new layer, and we will create, of course the weight should be at 1, you should also make the IK pass, because we are using IK for where we are looking, if we are looking up and down. And the upper body, of course, as the name suggests, is only selecting the upper body. Now we do some experiments with shield and just for the left arm, which is just a mask that has the left arm, but the animations are not that great, so I'm not going to cover it, but it's pretty much the same as the other body. Now, if you noticed a little bug that it didn't let me rename this, but not working, so let me rename this. You will have them inside your animator. This will be blend 3.0 and this will be blend 3, so keep in mind that. So for the attacks, we want an attacking boolean so that we know we're attacking. This is a float of attack, and you will see in a bit what it is. And the attack type is which one of these attacks we will actually play. Now, if you have more weapons, which you probably want to have in your game, you will create another integer which will be weapon type, the same way we had it into our third-person shooter series. Now, transition to attack, we will have two conditions: if we are attacking and if we are, and what type of the attack it is. Now, inside this, these are not actually states, but these are blend trees. And you will see over here that you have two states. One that is on hold, so if I'm pressing the left mouse button and I'm keeping it pressed, and if the attack is at 1, is actually the end of the attack. Now, don't worry for this rotation. Okay, this is not the final way, it only shows the upper body. So how fast we are moving this value is actually how fast we transition from the attack state, from the holding state where we hold our weapon, to the attack state. Now, of course, if from the time it takes for him to go from 0 to 1, if this is interrupted somewhere, we'll change the target value we have for this, so it will return back. So you actually interrupt the attack way like this. Now, you do not have to use only two states. For example, attack 3 is actually 3 positions. So one is when we are holding the weapon, one is around the middle, and the other is at the end. Now we made it this way because if you see, if it's from the hold, if it went directly to the end, you will see that it doesn't look that good. It looks a little bit like it's missing, so it looks like he's only moving it to the front. He's straight away doing it that way, but with this way you can see, although it's not that apparent, you can see that is actually making some more effort to reach out from his position. So now, of course, there is another way you can do this. Of course, you can create this, instead of having this blend tree, is create the state, another state, the holding state and the end state, and set up a trigger that plays the animation straight over here, and if it's interrupted, it returns back to to the holding position, and that in turn returns to the empty state. Now I didn't do it this way because the way I have it right now, we get a little bit more control, and you can control the transition without having to go into every one of these and change values from over here. Now from the attack, of course, we will only return to the empty position. We will only return if the attacking is at false. Now this actually is not empty, it has the idle animation over here, so he's holding, so the upper body holds the weapon like this even when we are moving. Now for the blocking, you will need a block boolean and the block side, which is a float, and you will see in a bit why I use the float. And as for the shield boolean, now I didn't use it in the end, so delete it or skip it, but if you delete it, you'll have to also delete this layer. So for the blocking, if we block, if the block is true and if the shield is false, of course it will always be false, but as you see here, it's only one state. So instead of having 3 different blend trees or just states for blocking, I just made a simple blend tree and I changed its position. So if the value is at 1, he's blocking to the left side. If it's at 0, it's blocking to the right side, and if it's at 0, if it's at 2, it's blocking to the right side, and if it's at 0, it's blocking to the upper side. So that's about it for the animator. Okay, the fewer values we have over here, the fewer stuff you will have to pass from the animator, from the network if you are planning to do multiplayer. Okay, keep that in mind. And I think we are pretty much done to start writing our scripts. Now of course, if you have better animations, or if you have well, it actually goes to if you have better animations. If you have better animations, you can just scrap all this and just make it with triggers and stuff like that. But of course, these animations are just stationary poses, which are way easier to animate and to create by yourself without having knowledge, too much knowledge about animations, because it's just a simple state, and we left the interpolation to be handled with mechanic. So let's go back into our scene, and on our character, let's start and create. Now most of the scripts are not actually mine, so they are from Unity, so let's create a new folder to write our scripts in. So let's create, and let's name this player controller. Of course, open it up. Let me bring that over here. So some of the stuff we have already wrote in previous videos, so I'm going to copy paste some. But first let's start writing our variables. So we need a reference to the rigid body, of course, and a reference to the animator. Now we'll need a public float, which is going to be our speed. Now keep in mind, whenever you see this was asked in one video, so let's just answer it over here. Now you will see me write a lot public, but you should only be using public variables if you are going to access scripts, if you're going to access these variables from other scripts. If you want to just send stuff from the inspectors and you know you're not going to access these variables from other scripts, then just simply use serialized field. Okay, so but I'm always writing public because public is shorter than serialized field to write every time. So we need another public float, which will be our turn speed, which of course is how fast we turn. Now we need a vector 3, which is the direction our transform is looking, and another vector 3, which is going to be the look position, which we are going to use for the body IK, so that we can look up and down. We need a reference to our camera. We need a reference to our camera forward, and we need, let me see what else we actually need. Now let's start with this first, and we will return in a bit. Now on start, of course, rigid body equals get component rigid body, and camera equals camera dot main dot transfer, and we actually need a reference to our capsule collider, and our capsule collider will be get component capsule collider, like this. Now let's make some more variables actually. Vertical. So this will be the axis for our inputs. Now we need to set up the animator, and the way we set it up, of course, is we have done this before, so I'm just going to copy paste it. Okay, pause the video and write it up if you don't know what this is. We simply get the animator, we search every children and for animators, every child game object, and from the first animator we will see, we check if it's the animator we currently have, we take the avatar and we destroy that animator. So we take the avatar from the model inside. Now of course we need to call this inside start, and we are pretty much done with this. So on update, the only thing we are going to do is actually we're not going to use this, so screwed, delete it. And on update, the only thing we're going to do is create a new array from camera dot position, and for the direction will be camera dot forward, and from that array we want to get a point from that array, and we will use get point. Let's give it something like 100. Of course, if you find a different value that works for you, you can use that. Now that is all about update. Now since we want to move with physics, we will use fixed update. Now on horizontal, the horizontal will be get axis horizontal, and the vertical will be input get axis vertical. Now, since we want to move, the simplest way we can move is, of course, rigid body dot add force or add force, and then simply do transform dot right is multiplied by horizontal plus transform dot forward multiplied by vertical, and all this will be multiplied by speed subdivided by time dot delta time. Now let this settle in for a while. What we're doing over here, we have two vectors. Okay, we have the right of our character and we have the forward of our transform. If we want to move forward of our transform, we multiply the vector by the vertical. So this returns, if the player is pressing the W or S, it will either return 1 or -1, and this will actually be that position. So this will return a vector 3, which is actually going to be 1 or -1. 1, of course, multiplied by the speed will return the value, how fast we are moving, so we will move forward to that direction. The same for the horizontal, and we add these vectors together, because if we multiply them, then if the player didn't press the A or D or W and S, so if the player wasn't moving to one axis, it will always return 0, so the player will never move. So if we jump back right now, let's start seeing in action. Let's drop it into our character over here, and when we hit play, you will see that I'm actually sliding over here, but if I press W or S, and if I press A or D, which it doesn't actually work that great over here, it's actually moving forward and backwards. So let's jump back into our script. So let's find the direction, which of course is a transform dot position plus our camera forward, and let's multiply that by 100 so we're not just too close to our player. And from that direction, from the direction position, we need to actually now find the direction, which we do it by subtracting from the direction position from our position. We zero in the Y, since we don't want to move, otherwise you will have problems with your character rotating towards down. And then we will change the rotation of the rigid body to equals quaternion dot spherical lerp from the transform dot rotation to the quaternion dot look rotation. We will pass the direction, and we will pass the turn speed multiplied by time dot delta time. Now we need a way to check for our physics to change, because we are sliding when we are pressing any key, when we are stationary. Let's create public physics material. One will be 0 friction and the other will be maximum friction. So inside fixed update, or let's write it as a different function. Let's name it this handle friction, and then if horizontal equals 0 and vertical also equals 0, then the material of our capsule collider will be maximum friction. In any other case, the material of the capsule collider will be 0 friction. Okay, so you can take this and drop it inside update or fixed update or whatever you like. So with that out of the way, let's fix the animator also. And of course the way we do this is anim.set float forward horizontal. The damping time will be 0.1 time dot delta time, and once again sideways. Well, you can give it a better name. Vertical 0.1 time dot delta time. Okay, simple enough. So with that, we should already be able to move around. Now let's let it compile first, and let's make this 20 and the speed 0.5, and we probably forgot something, I think, or no. Okay, so if you Google for, if you haven't zero friction, or if you do not have these physics materials, these are from the standard assets. You can create the new one. These are the settings for maximum friction. These are the settings for zero friction. Okay, pause the video and create them if you do not have them. Let's assign them. So zero friction will go over here and maximum friction will be over here. So in theory, if we hit play right now, for some reason it doesn't. We have a little bug with the sideways movement, which we will see in a bit why it happens. So we can move forward and backwards. Alright, so let's jump back into our script and let's see why we have this problem. And it's probably somewhere over here, since this is the only place we add forces, and we have transfer.right multiplied by horizontal plus transfer.forward multiplied by vertical, and we actually only applied the way it is over here, so be careful with the parentheses. Okay, the problem over here is that we only apply the speed with this vector. Okay, and so this, which is the left and the right, it actually never, even if it's at 1, it's pretty low speed, so it cannot be multiplied by this. Now the way we can fix that is delete this parenthesis over here and add it here. So it first, of course this is basic math, okay? The vector it will return this will multiply it by speed, and now it should work as it should. Let's see, make sure, and it works just fine. So let's see our attack animations. Now if you remember what I said in the beginning of this video is when I first click I have half a second to move the mouse, and it will choose what from what position it will attack. So let's see how we can make that. Let's create a new function so that we do not clutter everything up. So we'll name this void control attack animations. So let's add our attack variables. Let's leave a comment over here. Now for the pattern, as the pattern, the scripts from the pattern world, I'm going to organize these scripts a little bit, just to make it more appealing. So attack variables, we need a float for our target value, we need a float for our current value, we need a public or serialized field, remember what I said before, which is going to be the lerp rate, and I'm going to give it something like 10, or let's make it 5 actually. Now we need a boolean which it will serve if we're holding our attack. We need a boolean that we actually attack, and we need another public float that is going to be our attack timer, and we'll give it the value of 1, and we need an internal attack timer. So we need another float that is going to be the decide the time it has to decide. Now you can also make another one. This is going to be the internal. You can make a public another public float that is going to, you can change the decide timer from the inspector, of course. And since we are here, let's just add the block variables, and the blocked variables will be, if we are of course blocking, we need an internal float for a block timer, which is not how much time we can block, it's after we hit something, how much time you can return from, we can recover from our attack being blocked. And we need another public block that our attack has been blocked. So we have our variables, and let's go to our control attack animation. So let me close a little bit stuff over here. Now actually let's just add the variables over here so that we do not let's create a mouse X and a mouse Y. let's create the mouse X, and this will be input get axis mouse X, and mouse Y. I bet you can guess what it will be. Mouse Y. Now we need to know when we first click the left button. Now you can do it with input.get mouse button down, but a lot of the times it will not work too good with get mouse button up. So let's create our own input for that, and we will create a new float which will be named mouse button, or let's rename mouse left button, and we will get the get axis fire 1. Now of course all these are from the input manager. If you go into edit, project settings, input, okay, you will see that fire 1 has the alternative positive button is mouse 0, and the same for the from the right mouse button, the alternative is mouse 1, and mouse X, mouse Y. If you have different names, you will have to use the names you have in your project. So this the axis, what we know about axis is that if the axis, the left mouse button axis, is higher than 0.1, that means the player has clicked the mouse. Now we increment the decide timer, and this timer is actually how much time will the player have to move the mouse around. But before we do the logic for that, let's write how he can change, how you can decide where, if you move the mouse to the right or to the left, what animation to play. So we want to take the absolute value of both mouse X and compare it with the absolute value of mouse Y. So even if it's the axis is negative, so if it's pointing the mouse down or to the left, it will always compare them as they are, if they are positive. So if the X is higher than the Y, that means that the X is, it overcomes the Y, so it plays, so he's looking towards the X position more, so it will play that position. Now for as for the X, we want to check if the mouse X is lower than 0, that means he's looking to the right. Then we will set the unset integer attack type, or maybe yet let's just make this, let's make this attack type, and outside of our if statement, so the set integer will be the attack type, so that we do not have to write this every time. Of course we have to initialize it first, we initialize it with 0, so we do not have to copy paste this inside our if statement every time. So when the X is lower than 0, so that means it's looking to the right, so our attack type will be 2. This is the way I've set it up inside the animator I provided in the links below. Okay, if you have different values in your animator, add the value you want to use. So if the mouse X is 0 or greater than 0, the attack type will be 1. And if the Y is greater than the X, then the attack type will remain 0. Now if it never goes over here, it will be 0, so it doesn't matter what. You can even skip it, but let's just add it for good measure. Okay, so we have the way we decide which attack to play. And now, if the decide timer is greater than half a second, you can choose your own decide timer, how much time you give him to attack. Okay, then we want to say hold attack to be equals true. We want to set the attacking boolean in the animator to be true, and the decide timer to be 0. So what we need to do now, outside of this, of the left, let's make a region actually. Region, decide attack, attack type, and the region, so that we can collapse this and we do not have it inside our view all the time. So for hold attack, if the hold attack is true, and if we actually attack, which means we left the we do not press the left mouse button. And how we do that? We simply do a check if the mouse left button is lower than 0.1f, which means the player did not press the left button anymore. Then we need to add a new check, because otherwise if we do not check that we previously have pressed down the left button, then he will always be attacking. So if there is no input on the left mouse button axis, that means that the player isn't pressing he doesn't press the button. And if he doesn't press the button but we previously were holding an attack, then we simply attack. Okay, pretty simple stuff. So when we attack, we want to add to attack timer so that we know we are not attacking indefinitely, and we can have control, pretty much more control over the duration and of the transitions from the animator. Okay, and it's better this way, trust me. So we want the target value to be equals 1. This value will be and if he wants to play, this value will be the target value we want this to have, this over here. Okay, so target value, we initialize it as 1, and if the attack timer is greater than attack timer, the internal attack timer is greater than the attack timer, then we simply make it false, the attack to be false, and we change the set bool the attacking to be false also. We reset the internal attack timer and we reset the target value to be also 0. So just in case the attack was somehow opened, it will also reset after a few seconds. But what we need right now is, even if we are not attacking, so if you hold an attack but you're still not attacking, then we want the target value to equals 0. Now, if we also do not have if we are not holding an attack, we also need to have the target value to be at 0. Now, this might look a little bit messy, but it works, trust me. So, after we have the target value, we set up the values over here, and what happens, and when the target value is reset, the only thing we need to do is take the current value and make mathf dot move, either move towards or a lerp. I prefer the move towards right now, or you can create a different interpolation, and if you remember we covered that in a previous video. So our current value, we want to move towards our target value, and time dot delta time, all this will be multiplied by the lerp rate, and the only thing left to do is pass the set float, the attack float in the animator, to pass it as the current value. And right now we of course need to take the control attack animations and drop it either inside fixed update or inside update. It doesn't matter much. Now, the only thing that this pretty much works as it should, and let's test it just to be sure. And it works as it should. Now, but there is a little problem here, that if I start hitting a wall, it's actually the target value will never, and it will never ever be 0 if we are hitting a wall. So what we can do, let's close a little bit the inspector. So, and we actually got a null reference, and it was on the sort. So anyway, let's get rid of this, and then this actually, we'll see later. So let's go to the sort, and let's start adding, let's create a new script. Let's make this sword, or maybe weapon collisions. Now let's open this up, player control, we bring it over here. Now this is going to be pretty simple. We need a simple reference to player control. Let's name this PC and with the underscore, so that we know this is our own player control. And on start, PC get component in parent player control. Okay, pretty easy stuff. And then void on trigger render collider, other simple stuff. Now let's start adding some checks. So if other dot game object dot tag equals weapon. Now keep in mind you shouldn't be using equals like this. You should be using dot equals whenever you have to do with a weapon with strings. So if our collider hits another collider which has the tag of weapon, or maybe we can use a layer, or you can use a layer, but let's just use tag. Then we go into our player control and then we say that the attack is actually blocked. Okay. Else, if the other dot get component, the other game of the other collider we hit, we can find a player control into his parent. That means it's a character. So it's either the enemy or it's us. But we need to make a check if it's the enemy or us. Let's write it like this. We need to do a check if the player control we found it's not equals our player control. Then over here we will write do damage, etc. We will do that on later videos. So if it's not any of these cases, then we'll probably either hit a wall or something that we can't do pretty much anything about it. So our attack is blocked. So let's save it. Let's go to our player control, and now whenever we hit something, we have this block attack and we turn it true and false. So over here let's add this blocked attack to also reset this, and after we do all these checks, okay, we simply check if our block attack, if the attack we did is or maybe yet let's just delete it. Let's just leave it and we will see how it goes. So if after we do all these checks, if the target value should be 0 or 1, if the attack is blocked, then that means our target value should be 0. So whatever value this is, which in turn we pass it on the animator. So if it's at half point between 0 and 1, the target value will return to 0, so it will play the previous animation. Now let's since we are already over here, let's take all this function and let's copy paste now. And I think I did. Alright, so instead of control attack animations, we only want to use control to say control block animations. Now mouse X, mouse Y, since we are already using them inside the above function, we will not use them anymore. Now instead of left button, you can rename to right button. So let's name right button, and this will be input get access fire 2. So let's do a few changes. Now this will be the same, decide timer, Attack type should be block type, be 0. Let's change everything. Mouse right button, and then now we do not want or maybe we might need this. So anyway, let's just delete this. We do not want this, either this, and actually we do not want any of this. So block type the same way as before, okay, but for the block side we have actually, I'm going to change a little bit. I'm going to make this 1, I'm going to make this 2, and this is actually a float, not an integer, since we are using we are passing stuff inside the blend tree, and this should be block type. So for let's make sure that it's actually block side, it's not block type. So let's rename this block side, and this should be set float block side, and we pass the block type. Alright, so after that we actually, what do we need to do? Then after we decide all this, on decide timer it will also be 0.5 seconds. Okay, so we set bool block to be true. We want the blocking to also be true, and the timer to reset, the decide timer. And we actually need to add all this inside a different inside an if statement, and we only want to do this if we are not blocking. And yes, okay, otherwise it will reset it, even if we kept blocking. It will also reset, it will change the position it was blocking, so it wouldn't be pretty. So if we do not press the right button, let's delete actually the regions. Hope I'm not too confusing. So if we do not press the right button, then we do not want to block anymore. And of course we want the blocking to be false. Set bool. Yeah, I'm not thinking too much. So let's change this. Actually, I've changed my mind, and I want to delete this from over here, the blocked attack, and I want to control the blocking all from the same function. Oh, it's better that way. So over here, if we have blocked an attack, our attack was blocked actually, then take the internal block timer and start adding to it with time.delta time, of course, and after a second then block attack to be false and the block timer to be 0. And that's about it, what we have to do through scripts. Over here, and let's drop it also in update. So let's see what we did. Let's maximize this so that we can see better. Let's hit play, and if I click and move to the left, I play the animation from the left. If I move to the right, plays it from the right. If I make it straight up, it strikes overhead. I think, I don't remember how it's called. And we, of course, now I noticed we forgot to add the IK stuff. So let's quickly jump inside. And as for the IK, it's going to be very easy. Simply do void on animator IK. Remember, everything that has to do with the animator has to go inside on animator IK. So anim set look at weight. Let's make it 1. We want the body weight to be something like 0.5, so he doesn't look with all his upper body, because it will break a little bit the animation, and I didn't like that. I want the head, the eyes, and I also want to clamp weight. And as for where we want to look, we pass the look position, which is the position we take from this ray over here. Okay, so now it should work as it should. If I look down, you see he looks down, and if I look way too up, he's also moving his head further more than his body. The attacks work as they should, from what I can tell. Okay, and if I click the right button, I can also block and also challenge other people, which of course we do not have any other people right now, but we will do in later videos. So if I go close to a wall or other collider, and that's actually didn't. Let's try another collider. Oh yeah, we forgot to add on the sword. Okay. We forgot to add the collisions, of course. Let's click play. And now, if I hit a wall or another collider, you will see that my attack gets interrupted. Now, first, let's see this. This is the barrel over here. It has actually a rigid body over it. Okay, so of course, since I'm using a trigger, I cannot hit it, but it disrupts my animation. But if I move it with a character controller, it will move. Now, one way we can do interactions with this is if we actually had a box collider over here, which is pretty similar to our trigger, and you will see that if we have one trigger and one box collider, it will hit the barrel and it will fall to the ground. Now you will wonder, of course, by having two colliders, why didn't I use straight the first collider over here? Now I'm not going to keep this because I do not care too much about it, so you can have it in your game, or if you want to be more pricky about it, you can have the collisions on a child game object and set them up from there, so you do not have two colliders on the same game object. Now why didn't I use the collisions straight from the beginning? So let's test that. On collision enter, collision other, and the only thing we need to change over here is we need to pass a transform to the other so that it knows. Actually this might not even need it, so that it takes it from the and this should be collision. So it takes the transform of the collision. Now if we hit play, let's test the collision it has. Okay, I'm almost touching the other collider, and you will see that because we are moving pretty fast, because we have fast movement, there's actually no impact, so the collisions never register. Now the other way, of course, let's see it in an even more slower rate. Let's make it this to 1. Let's find a wall. You will see that even at a lower rate we still have no physics, no collisions. Now that I think of it, of course, it might have something to do with the IK, but if I uncheck the IK, of course there is not going to be, the weapon is going to fall to the ground, so it's not something we can use. Let's see, let's make our lerp rate, and I changed a different lerp rate. Let's make it 0.5. You see how slow it has to go to register collisions. Now if you want, and I forgot to make this a trigger. Yeah, I'm pretty smart, yeah. Anyway, so let's make this at 1. Let's see if we can find it. Now of course there are other ways. If you are too much picky about it, you can do, you see, at 1 nothing happens, so you have to go pretty slow to find collisions. So let's just do it the other way around and be done with it. Okay, now if you want to be way too picky about it, you can actually have start doing a raycast from take some points over the sword, for example, and start doing a raycast from the up, down, and if you are close to the tip, and of course to the negative forward vector. Okay, so you will actually take the collision from the raycast which is more reliable than the physics, to see if you are blocking if your attack was blocked. But I'm only going to use triggers, since why not? They are easier. So collider, and I think we are pretty much done with this tutorial. Let's hit play. So if you want collisions with game objects like this, and I forgot to make the sword a trigger. Oh, I didn't. So we see how to make attacks that can be interrupted, and of course we need to raise a little bit the lerp rate. Let's leave it to 5. I think it looks pretty good. Now, of course, as the previous series, if you have better animations, this will look even better, and you'll see that in 1 hour and a half we actually have prototyped a game, and with some totally free assets you can have a game that looks pretty good actually. And actually I can say that it looks like a AAA game with no effort at all. Okay, I didn't spend even $1 on this. Now that's not totally true. I spent for the image effect, since they are bought from the asset store, but these are image effects that I use on all the projects, so the real cost is nothing compared to how much I use them. So this is it for this part of the video. Next video we will add some enemies so that we can have we can start shooting. I got carried away from the previous series. So we can have some enemies to hack and slash around, and we can have location damage upon them. Okay, and we will do some mounts and the other stuff I mentioned in the beginning of the video. So thanks for watching. Don't forget to like and subscribe. You can support me on patreon.com/csharpaccent, where with $5 or more you can get access to a Google folder where you will find all the scripts. I also get a lot of emails that they ask if I will accept any job for pay me for doing some jobs. So if you want some commission done, send me an email and I will review it, and we can talk further from email. So you do not have to comment, just send me a pitch email and I will see. Now of course I don't promise I will do everything, and yeah, I'm doing that because I'm sure you have noticed, or if you watch what happens in Europe right now, Greece is pretty much fucked. Okay, so we just try to open up a little bit because the future is uncertain, and of course the future of the channel, I'm going to continue making videos, but I don't know for how long. Okay, because right now things are pretty bad. Of course, supporting me on Patreon helps a lot more than you think, and in return you will get the scripts in the video, so you will not have to write them, and in turn support me and our little community. So enough with my rants. So I'll see you next time with some enemies to stick our swords into their throats, and you know what happens when you stick a sword into the throat of someone. So I'll see you next time.